This is a CCEA, GCSE Maths M8 Paper 1, so it's non-calculator, and it's the one from the November 2022 series. This one's actually on Thursday the 1st of December. This day we're looking at question 1. A shape has a perimeter of 16 centimeters and an area of 10 centimeters squared, is enlarged using scale factor 2. What's the perimeter of the enlarged shape? So straightforward enough one. This perimeter is just going to be doubled because it's a length, and so it's going to be 32. How many times bigger is the area of the enlarged shape than the area of the original shape? Now area then is a wee bit different. If the lengths are in the ratio 1 to 2, that's what scale factor 2 means, then the areas are going to be in the ratio 1 squared to 2 squared. You've got to square that, so that's actually 1 to 4. It doesn't even ask you really that it's going to be 40, it just wants to know how many times bigger. So the answer to that then would be 4. Each interior angle of a regular polygon is 140. How many sides is a polygon? So polygon can look a bit like that, and if that's 140, the best way to do this one is to find that the exterior angle then is going to be 40. Remember, the interior and exterior angles add to 180. If it's a regular polygon, it's all 40s all the way around, and they always add to 360. So if we do 360 divided by 40, the answer then is going to be 9. The diagram shows a section of coastline with a lifeboat station marked at B and a lighthouse marked at L. So that's it down there. A sinking ship sends a distress signal. The ship is less than 70 kilometers from B and less than 30 from L. Using a scale of 1 to 10, shade the region where the ship could be. So obviously then, if we have 70 kilometers, that's going to be 7 centimeters, and 30 kilometers, that's going to be 3 centimeters. So we need to set our compass to both of those and then work out from there. So it's 70. So we need to set that then at 7 centimeters. So there's my 7 there, and then that's hitting just about the right place then for the 0. So from B, less than 70, so I'm going to mark that off there like that, and then 30 from L, and so we have that. And so my shape is going to be there. So it has to be somewhere in this little region here. And that's us for that. Question 4. Tom has some 20p coins and some 50p coins. The total value of Tom's coins is £8.60. Shauna has twice as many 20p coins as Tom, but only half as many 50p coins as Tom. The total value of Shauna's coins are £8.20. Find how many of each type of the coin Tom has. So we're going to go 20x plus 50y is 860. I like kind of keeping it rather than 8.6. I don't like working with the decimals there, so just changing it into pence. And then Shauna is twice as many 20p coins, so if Tom has x of them, then she's going to be 20 upon 2x plus 50, half as many of those, so it's a half y, and hers comes into 820. So that gives me 40x plus 25y is then 820. I'm going to call this equation 1, this equation 2. I'm going to times this one by 2. So it's 1 times by 2, and that gives me 40x plus 50y is then, times it by 2 is then 1720. That's equation 1. Because I can see if I do this, take away this, I'm going to get a negative. I'm going to do 1 take away 2. 50y take away 25y, and then 1720, and that then comes to, if I subtract those two, I get 900, I think. Wait, I've made a terrible mistake, a very silly mistake. What am I doing? I'm timesing those each by 2, so that's 100y, of course. This is going well. 100 take away that, so that's 75y, and then that's 900. How do you work out how many 75s there are in 900? Well, 2 75s would be 150, so 4 75s, 250 is 300, so it's going to be 12. So y then is going to be 12. Substitute it into either of your two equations, so I'm going to substitute it into one. 20x plus 50 upon 12 is 860. 20x 5 12s are 60. So that would then be 600, which is 860. That gives me then 20x 600 take away 860 is 260. So x then is 13. We are just checking as for what Tom's are, so his were x and y, so it's going to be then x is 13 20p's and then 12 50p's. 5a, it says the lines y equals 2x plus 1, gradient of 2, y intercept of 1, so that's this one here. And x plus y equals 4, that's this one here. If you rearrange it, you get y equals minus x plus 4, gradient of minus 1 of 4 is drawn in the grid. By drawing another line in the grid above, indicate clearly by the letter R the region satisfying these. So we want to draw the line then x equals minus 1. The line x equals minus 1 is going to be this line here, any one where the x coordinates are minus 1. So a nice thick line going there, and we want where x is greater than minus 1, so we want this side here, so I get rid then of the other side. We want y is greater than 2x plus 1. Now this isn't always the case, but we want then above the line, so I get rid of below the line. The other way you can do it is pick a point not on the line, for example 0 0, and sub it in there. 0 is greater than 1. That's not true, so it's not true on that side of this line, so it must be true on this side of the line. And then x plus y is less than 4. Again, if you want, pick a point not on the line and see if it's true, but we want then above here. We're told to label that one then R. On to part B. Again, they've plotted two lines for us here. I've been drawn on the grid. By drawing another line in the grid above, indicate clearly by the letter R. Wait a minute, this is the same question. I'm not sure where a repeat has come out of that paper, but that's okay. It's this one here. By drawing more lines on the grid above, indicate clearly by the letter B the region satisfying y is less than 2x. X plus y is less than 4. That's the line we have. And then y is greater than or equal to 1. So we want to plot y equals 2x. Y-intercept is 0, and it's the line y equals 2x, or you could pick some points on the line and that would work as well. So that's that line. The other one is y equals 1, and that's going to be then the one where the y coordinates are all 1. So we have that. So y is greater than 1. We want above this line, so I get rid of below it. X plus y is less than 4. We've been there with this one. We want there, and then we want y is less than 2x, so one kind of lower than that line. Again, if you don't like that method, pick a point not on the line, and that will be it. And we're asked then to label that one B. Question 6. Complete the table for y equals x squared plus 3x minus 3. Let me see. So we're going to substitute in minus 3 into here. Minus 3 squared is going to give me 9. Minus 9, because 3 times minus 3. Take away 3. So that gives me then minus 3. And we need to substitute in the number 2. That's going to be 4 plus 6. Take away 3. And we end up then with 7. draw the graph of y equal x squared plus 3x minus 3 from minus 4 to 2. So it's minus 4, 1 is a coordinate. Be careful with your scale here because this goes up in 2s, whereas this is kind of in 1s. So it's minus 4, 1, minus 3, minus 3, minus 2, minus 5, minus 1, minus 5, just reading from the table, no, you can't see it at the minute, 0, minus 3, 1, 1, and then 2, 7. And so with that, of course you can just kind of turn this around. I find it easier kind of going in the inside of here. That's that bit of the curve. And then bringing it on up to here. Rough there. So we have something like that. It's not a great curve, but you get the idea. Use your graph to estimate the solutions to x squared plus 3x minus 3 is 0. See, they've exchanged then the y for a 0. So it's going to be this line here, and it's this point here, and it's this point here. So I reckon that's 0.8 and minus 0.8. It's supposed to be symmetrical despite how badly I've drawn it. And so we have that. In fact, what have I done here? There's some messy things around here. I think that should be a minus 3 there, so it should actually have kind of gone through there. But you get the idea. And that's a wee bit better from there. Apologies. Anyway, that's 0.8 and minus 3.8. So minus 3.8 and 0.8. That are my guesses for that one. By drawing a line on the graph, show that. So it's x squared plus 3x minus 3. It's not too difficult, this one. They have let y here equal x plus 1. See, they've exchanged the y for an x plus 1. There's the original one. Y equals x squared plus 3x minus 3. X squared plus 3 minus 3. So we want to draw the line y equals x plus 1. So how does that look? That has a gradient of 1 and a y-intercept of 1. Again, be careful here because the scale's a bit funny. So it crosses of 1 and then a gradient of 1. So that's actually a cross 1 up 1, a cross 1 up 1, a cross 1 up 1, and so on. And so we want to draw that line in there. Just being careful, you know, with your scale. And we're trying to work out then where these cross. So it's crossing here. And it's crossing here. I think that's like minus 3.3. And I think that looks to me like about 1.3. Minus 3.3 and about then 1.3. Write down in the simplest form the quadratic equation that has been solved. So we're effectively taking everything then to the other side. So we would be taking x from both sides. That would give me x squared plus 2x, and we're taking 1 from both sides. That would be minus 4, and that equals 0. So x squared plus 2x minus 4 equals 0. Hope you see what I've done there. It's from the previous one. We're trying to get this equal to 0 and over to there. What line would be drawn on the grid to solve x squared plus 4x minus 6 equals 0? So I would kind of set it up. We'll do it over to the side here. X squared plus 4x minus 6 equal to 0. And we want to get that back to what curve we have. So we have x squared plus 3x minus 3. So we would take away x from both sides. That would give me x squared plus 3x minus 6 equals minus x. And then how do you get from minus 6 to minus 3? We would add 3 to both sides, and minus x plus 3. So we'd need to draw the line then y equals minus x plus 3. I think those questions are tough enough. Write the decimal number 15 as a binary number. So you can just see that now. So 1, 2, 4, 8, 16. We can't have a 16. We want an 8 and a 4 and a 2 and a 1. Add those together, you get 15. So it's 1, 1, 1, 1. Binary number this. So again, we need 7, 1, 2, 4, 8, 16, 32, 64, and we have 6 0 0 0 0 0 0 0 and then a 1 here, so it's going to be then or 64. Change this into a fraction, so we can see then there's two numbers repeating. So we're going to, I will let x equal 0.081881, and then I would times it by 100 because there's two numbers repeating. So I'm going to do it above actually. So 100x equals 8.18118. Once I subtract those, I get 99x equals 8.1. So x is 8.1 over 99, or if you want then 81 over 990. Hopefully it's reasonably clear that they divide down, they both divide by 9, so it'll be 9 then over 110. And we end up with that. Question 9. 8 minus 6 and minus 8 6 are ends of the diameter AB of a circle. What is the center of the circle? So the center of the circle is going to be the midpoint of those two. I don't know if we can kind of see that, so let's do a wee makeshift diagram. This is not accurate in any way, but say that's a diameter, and those are the two coordinates. That's the ends of the diameter. Obviously then our kind of midpoint is going to be that. So you can use your formula or just take a wee look then to see where it's going to be. So halfway in between 8 and minus 8 is of course 0, and halfway between minus 6 and 6 is 0. If you want to do the formula, you do 8 plus minus 8 over 2, that gives you 0, minus 6 plus 6, and we have that. What is the equation of this circle? So we're going to then have to find our radius. So what's the center of this circle? What's the equation of this circle? Do we know? It doesn't tell us in a radius, so we need to do a bit of Pythagoras then, I think, to work that out, unless I'm missing something. So if that's the point 0, 0, and that's the point, let's see, minus 8, 6, using our distance formula then, it would be the square root then of 8 squared plus 6 squared. So then we're going to get 64 plus 36, which is the square root of 100, and so the distance then from here to here is going to be 10. The equation of a circle then is going to be x squared plus y squared, and it's r squared here, so that then would be 100. What is the gradient of the diameter AB? So again, you can kind of pick any points here. I suppose we should kind of pick these ones here. So let's see. We have 8 minus 6. That's not very accurate, but that's okay, and minus 8, 6. And our m is then y2 minus y1 all over x2 minus x1. So if I want then my y2, let's go for 6 minus 6, and then here is minus 8 minus 8, and then it's going to give me 12 over 16, doesn't it? It doesn't give me 12 over minus 16, which is then minus 3/4, so minus 3 over 4. Find the equation of the tangent to the circle at A. So A is the point 8 minus 6. If the gradient of the diameter at that point is minus 3/4, then the gradient of the tangent, so that means gradient of tangent, is going to be the negative reciprocal of that. So that would be 4 over 3. Do you see what I've done? I've turned that upside down to get 4 over 3 and got rid of the minus. So that means it's y equals mx plus c. Y equals 4 over 3x plus c, and I'm substituting in this point here, so it's a point 8 minus 6, so that's minus 6 equals 4 over 3 upon 8 plus c. not spacing this out very well. Minus 6 is then 32 over 3 plus c. So I'm going to take this then over to the other side. This spacing is awful, apologies. So it's minus 6 minus 32 over 3 plus c. Minus 6 in thirds would be minus 18 thirds. So c then is going to be minus 18 minus 32, so minus 50 over 3. So it's going to be y equals 4 over 3x minus 50 over 3. Write down the equations of the two tangents to this circle which are parallel to the y-axis. So what does our circle look like? Centre 0, 0 and radius 10. And so parallel to the y-axis is going to be this line here and this line here. If a radius is 10, we're going to have a minus 10 here and a 10 here. That means that's the line x equals 10, and that's the line x equals minus 10. Find the points of intersection of these tangents with the tangent A. So the tangent A, let me see, what way did we have this? Obviously the x coordinate is going to be 10, so we would sub that in then to our equation. So let's get our equation back from the previous one. 4 over 3x minus 50 over 3. So if we have x is 10, then y is, so that's going to be 40 over 3. Do you see that there? So 4, because 4 times 10. So 40 over 3 take away 50 over 3. So that's minus 10 over 3. And then the other one is going to be x is minus 10. So that's minus 40 over 3 minus 50 over 3. So y is minus 90 over 3, which then is minus 30. So my points are minus 10 minus 30. And this other point then is 10 minus 10 over 3. Question 10. For each of the right angle triangles above, state whether the length of the hypotenuse is rational or irrational, giving reasons for your answers. So we need to use Pythagoras then for each of these. So let's see what this one gives us. We're going to have c squared equals a squared plus b squared. That's obviously our Pythagoras theorem. So for our first one here, c squared equals 6 squared plus 13, because if you square the root 13, we get that. So we get c squared 36 plus 13. I think that gives 49. And so c then is going to be 7. That's really an a there, and that's a bit confusing in terms of we have that. So our a then is rational because a equals 7. For our second one, let's change it to b squared equals, that's supposed to be an equals 25 plus 49. Are we okay with that? So b squared is 25 plus 49 gives me 74. So b is then the square root of 74. That's not a whole number. It's not a decimal, or it's very nice. It's, it's an irrational number. So that's irrational. And that's because b is root 74. And then finally, then we're going to have a bit of surds to multiply out. So let's wait and see. So we're going to do this squared plus this squared and see what we end up with. This is a wee bit of a messier one. So we'll do it down here. So we have our c squared equals 2 root 11 minus 3 squared plus 6 plus root 11 squared. c squared is 2 root 11 minus 3 upon 2 root 11 minus 3 plus 6 plus root 11 upon 6 plus root 11. C squared equals 2 root 11 times 2 root 11. So we need to be careful with this one. Root 11 times root 11 gives me 11 times 2 times 2, so that's 44. Outer and inner are going to be the same. They're minus 6 root 11, so that's going to be minus 12 root 11, and then plus 9. Over here then, plus 36 plus 6 root 11 plus 6 root 11. Do you see what's happening here? That gives me 12 root 11, and then the root 11 and the root 11 multiply together to give me 11. So the minus 12 root 11 and the 12 root 11 are going to cancel, and we have 44 plus 9 plus 36 plus 11. So that gives me 20, that gives me 64, 36. So it actually gives me 100. C squared is 100, and C then is 10. So that one's going to be rational. Wee bit of working on that, but we got there. Because C equals 10. Finally, I think question 11, prove that one of the above is a prime number and one is a surd. We just need to try and work these out, I suppose, and kind of see what we end up with. 4 to the power minus a half. The half means square root, so that's 2, and then that then gives us a half. Half means square root, so that would give us then 1 over 3. And the minus means 1 over, so that then would be 3 over 1. So that one then comes to be 3. So that's a prime number. So that one's prime. 64 to the power of 2/3. That means you find the cube root of 64. That's what the 3 means there. That gives me 4, and then you square it to get 16. I'm going to come back to this one. 1 to the power of 5/7. We're lucky here. The 7th root of 1 is just 1 to the 5 then is 1. So that's not a surd, so I'm hoping this is a surd. So we got to then find the square root of 3 and then cube it. So it's going to be the square root of 3 and then cubed. So that gives us root 3 times root 3 times root 3, which gives me 3 root 3, which is then a surd. So that would be it then. So I guess just a wee final thing. A 9th to the power of minus a half is prime, because it's 3, and then 3 to the power of 3 over 2 is a surd, because it's 3 root 3. And that's us done.